Welcome back to the PLC Professor's Workshop. This is going to be number 9 in a series on the CR30 Programmable Safety Relay. And for several sessions now, or discussions, we have been doing circuits. And we are kind of following the progression of what they have in the user's manual or the wiring diagram manual, because we want what you see here to match what you're going to see in the field when you go to the documentation and whatever resources the manufacturer of this product supplies. So the first thing we're going to do is we're going to add feedback. Now, feedback is, it feeds back the state of K1 and K2, basically. There's a number of ways to do it, and the difference in the two different methods has to do with being able to resolve which contact or which device isn't up to snuff. We're not going to worry about that. We're going to keep it simple. And so let's go look at the diagram first before we look at the actual hardware. Let's do it. Let's add another element to our electrical design for the 440C-CR30 22BBB. If you are fresh into this series, you need to go back and watch most of the first 8 discussions, because we're not going to repeat everything in every session. This time we're going to add an element of feedback. This is a basic illustration of adding feedback. We have 2 contacts in series, normally closed contacts, and on terminals 18 and 19, these are safety outputs. We have K1 and K2. K1 and K2 are force-guided safety relays. Of course, K1 and K2 normally closed contacts, one each from one of those 2 relays. This diagram shows it going to input 0. But in our circuit that we've been building, we already have a 2-channel e-stop button going to 0 and 1, and we have a 2-channel enabling switch, handheld enabling switch going to 2 and 3. So we're not going to put our feedback into 0, input 0, it's going to be input 4. Notice that K1 and K2, these normally closed contacts, are the feedback is being sourced to 24 volts DC. Not to a safety output, not to something like, terminal 12, 13, 14, 15, 16, 17, one of the multi-purpose. We're just going straight up 24 volts DC. Now, there may be an instance where you have to use test pulses and you have to source it to something else to meet your SIL and category rating that your customer or plant requires. And when you think about ANDing 2 normally closed contacts, what you can say is if either or both K1 and K2 are open, there's not going to be 24 volts DC on input 0. If you put them in parallel, they're normally closed, then you could have both or either, and they would both have to be open in order to not get 24 volts at input 0 in this diagram. So if we're looking for them to both be in the same state, then we have to AND them. If K1 normally closed is normally closed in the closed position, normal, and K2, then we have our feedback. Here's another method, and that would be, now this has 4 safety relays, K1, 2, 3, and 4. Now I tend to label these K1A, K1B, K2A, K2B. That's just my preference. Let's ignore 3 and 4, K3 and K4. Let's just ignore those and consider K1 and K2, which is what we had in the previous diagram. We had just 2 normally closed contacts. Now the difference is that we are feeding them individually into safety inputs. The CR30 will know which one is not closed or which one is not open, whatever the circumstance is. Whereas here, if both of them are closed, we know it. And that's what we're after. If either one is open or both, it's all the same thing. Let's go look at the actual hardware. This device now has feedback added. What we did was we've tried to tidy up all of these yellow and purple wires. Remember that we are taking safety outputs 12 and 13 that you can't see behind the Ethernet cable, and we've multiplied them through these jumpered blocks so we can feed 12 and 13. So we can feed the safety outputs, which is going to be test pulses, to our enabling switch. We're pretending that this is a handheld enable switch, and then we have an e-stop switch. To this, we've added feedback. Before, we were just controlling these two relays, energizing them, de-energizing, K1 and K2. Now we've taken from 24 volts DC over here through that red wire into the common on K1, and then we came out the normally closed, went to the common on K2, came out the normally closed, and now we're going to safety input 4. However, it's wired up for feedback, but we don't actually have any feedback. We don't have a program in the CR30 that's considering feedback. So let's take a look at that. Back to Connected Components Workbench, you can see that we have our CR30 here with our Ethernet module and the expansion module. We did land the feedback signal on 4 up here, input 4 of our safety inputs. We could have landed it on any one of the inputs on this expansion module here. If you use one of these, then it's a safety input, but these are not safety inputs. In the case of feedback, it's not going to make a lot of difference. However, if you've got the safety inputs to spare, use them. So let's go in and look at the logic. Now, feedback is something that is taken care of in the safety output function right here. Remember, these are safety monitoring functions. We have an e-stop and enabling switch. The feedback has nothing to do with these safety monitoring functions over here. But we're going to add one right here. To do that, we open the toolbox and we go to feedback monitoring. We drag it over and drop it there. Coincidentally, it by default ended up on embedded input 4, and that's because that's the lowest unused embedded safety input. It just is coincidentally what we also use. So let's look at advanced settings, and we have a filter time. We're going to ignore that, and we're going to say we have one input, and this feedback function now is going to be referred to as safety monitoring function 3 of the feedback type. Notice that there's no output like there is on these. See the gray dots? There's no output. However, when we go here to feedback, if I had not added it over here, it would not show up over here. So we'll add it in there, and we still have the auto reset type. So that's adding feedback right there. Wired up, add the feedback safety monitoring function, and then point it to the safety output. So we're going to save this. I'm going to save it as, we still called it pulses, and enable with pulses, so we're going to add to that. I think I'll remove enable and then add feedback. Okay, now at this point we're going to download it. However, I do want to remind you that although we saved it, when we download it, we're going to overwrite the program that was in that device. Right now the run light is not flashing, which means that the project or program in the CR30 is verified. So I could build it first to see if there's any errors. I'm just assuming it's right, so I'm going to go to edit logic, and then I'm going to download. Remember, we could have more than one CR30 out there on the network, so we got to be deterministic about what we select and download to, because if you had 2 or 3 of them out there, you could download a program to the wrong one. I just heard it click, so it went into the program mode. You can see up here, not in run mode. Download successful. Do you want to change back to the run mode? So you see up here, okay, now you're in run and you're not faulted, but we're not verified. Let me go look to make sure that it's flashing. Yes, the run light is flashing, but you see there's nothing here to tell me that. At least I don't see it. I'm wondering if this tells me that it's not verified by saying verify it, meaning it's not verified, so verify it. So we'll click on that. Check off all of these questions. Just a reminder, when you do this, you're saying you did it. Okay, performing a safety verify will change the safety relay to the program mode. Proceed with safety verify. You'll hear it click. Maybe you don't hear it in the background, but it does. Okay, verify success. Back to the run mode. Yes. Okay, that answers my question. If this is grayed out, then it's been verified. You're online. See over here, connected. Over here to the right, connected. And this is grayed out, so I guess that is indirectly indicates that it's been verified. Otherwise, it wouldn't say verify. Now let's go to the logic. And we have an enabling switch that's grayed out, and we have feedback that's grayed out. So I'm going to hit the e-stop. Now this is interesting. I pushed the e-stop, I heard it click, but I didn't push the e-stop far enough down to make it latch. That's one disadvantage of that type of e-stop button is when you hit it, you have to hit it far enough so it mechanically latches. What I actually prefer myself is the momentary type that requires a reset push button. Okay, so now I've got feedback, and the feedback is green. So everything else is gray, so we've got gray and green. By the way, this green right here means nothing. I don't even know how you'd get rid of that. It's just a space of the last thing I clicked on. I could click down here. So that green means nothing. The only thing that's relevant here is that we are online and running. All the safety stuff is grayed out, but the feedback is green. And it is saying that the state of the two relays, K1 and K2, that are connected to embedded outputs 18 and 19 up there in your safety output function, that they are in the same state. So if I pull out the e-stop, or let's just grab the enabling switch. Okay, I pressed in the enabling switch. Remember now this is just a momentary push button with two normally open contacts. So I'm pretending that it's an enabling switch, and I'm pretending that I'm holding it in the middle position. If I squeeze it too hard, it does this. If I don't squeeze it hard enough, it does this. Just right. Oh, you know what happened? That's cool. Channel fault and discrepancy fault. I was pushing my fake enabling switch real slow, and that's how I got a discrepancy. Okay, to get rid of it, I simply operate it. In other words, just like the e-stop button, if you've got a discrepancy fault or a channel fault, in order to reset it, you have to demonstrate that the device that caused the fault now works properly. So I'm going to do the enabling switch again. So I did it fast. If I do it slow, I get a fault. In other words, I pushed the button down really slow because I knew that would allow one contact block to change state before the other one did, and you get both a channel fault and a discrepancy fault. Now I'm going to operate the button again, and see it's back to normal. Hit the e-stop, and our feedback is good. Pop it back out. Now let's go look at the hardware and do the same thing. I turned the lights out on the display here so you can more easily see the LEDs over here in case we get a fault. We have our feedback hooked up now, and we'll do an e-stop, and if you can always keep your eye right here to see if they are on or off. You can see the little windows open up. And we'll do a real slow, okay, we got a flashing fault over here. And we'll operate this again. So I'll bring this up here so you can see it. See, and the fault goes away. Same thing here with the e-stop. If I pull it up real slow, see, I got a fault. And if I operate it again, it'll go away. On a cheap e-stop or enabling switch like these, you may want to increase your discrepancy time because in the real world, we don't want these faults. I thought I was going to get more out of this episode or session than what I did. I was hoping to do the feedback and maybe do a reset or something. I either spent too much time pontificating, I'm not sure what, but we'll jump back in the next session and probably do a feed or a reset button. Right now we've got auto reset. Remember, I don't like the detent type e-stops where you hit it and it has to stay in order to stay off. Now, if you hit it and it didn't stay in, but it broke contact and you got your e-stop, and then you needed a reset button, that would be okay. And that's another way to do it, is you can use a e-stop that latches in mechanically, and then to reset it, you have to pull it out and you have to hit the reset button. Anyway, we'll get that in the next session. Thank you for watching.